Hey everyone, this is Bobby at Coppell TV Repair, and today I have a quick video showing you how to test power supply board Delta DPS-388, which is used in Vizio P652UI-B2. There are a lot of requests we got lately on whether the TV is bad because it does this and that. We have a lot of videos showing how to test all kind of power boards, especially DPS boards. This is nothing really highly different or specific. Really quick, not necessarily very correct, but very closely very correct. Every power supply board has one small transformer or small source, not necessarily small transformer. I'm already starting to make mistakes. Sometimes this is mixed with a bigger one, but it has a transformer which provides a small voltage called standby voltage, which is the very minimal essential power needed by the main board, which is the brain of the television, to be able to look out for when you are going to want to start it and to press a button or to send a command with a remote. And it needs some juice for that. It needs some voltage, some power, that it keeps it awake just enough to detect that request to actually start operating. This is called standby power, and it's usually passed by the main board, by the cable that goes between the power supply board and the main board. On the connector, you see two pins here that says 5-volt standby, and a bunch of pins where you have ground. What that means is that when you disconnect everything from that board and you measure the voltage on those two pins connected to ground or anything that is ground, it just so happens that the heat sinks here are ground. So what I can do is, the heat sinks are not always grounded, but on this board they are. So what I'm gonna do is I'm gonna stick my reader and see what I have. I'm making poor contact. Oh, come on. Okay, let me stick it here so that it's more reliable, and we have stable 5 volts. And they're passed by this small transformer, which again is small power, small voltage. It just provides the very essential minimum. Now, what that board is waiting is a signal from the main board that's going to come again on this connector that tells it, wake up, I need you to work. And then it's going to wake up a bunch of other circuits on it and starts providing other voltages. And you can see what you can expect. You can expect 12 volts to show up. They are not going to be here if you measure the board just like it is. And in other words, you do want to test that. You don't want to run that test with everything disconnected, because if there is a board that has failed, it may have shorted whatever component may have failed on that board. It may have shorted, let's say, the 5-volt standby pin. So there is a circuit that goes out of here, and if that circuit has failed, it is possible, not necessarily, not always, but it's possible that it may have shorted. And when that board tries to start up and provide those 5-volt standby, or any other voltage for that matter later on, it may be unable to do so, because imagine there is just somebody that has shorted this to the ground. And when the circuits on that board try to raise 5 volts, of course they wouldn't be able to, because there is a wire that connects the output straight to the ground. And of course you see 0 here and you say, oh, that board is bad. Now, it may not necessarily be bad. It may be an outside board that is shorting it out. So how the main board sends the signal back to here, there is a pin that is called PS on. That means power supply on. That means wake up dude, we gotta work. Different boards require different activation signal, but most likely, most commonly, either you gotta pass anywhere between 2.8 to 5 volts. It really depends on the board. It really does depend. There are all kind of varieties there. But the two most common ones are by sending it logical 1, which is anywhere between 2.8 and 5 volts, and this is one of those boards, or grounding that pin. Most of the Samsung plasma boards and many of the LED boards from Samsung do require that pin to be actually shorted to the ground in order for something to happen. And the way you find out that, the most easiest way, is to see what's on this pin when there's nothing connected to it. So what you want to do is you want to measure, this is 1, 2, 3, 4. 1, 2, 3, 4. What's here, buddy? And what is here is nothing. And what that means is that it wants something, not something, but 5 volts to be passed to it. The easiest way to do that is just getting a jumper. You can do it with a tweezer or something, but because you need something more reliable to stay on while you do measurements, you really do want to do a simple jumper like this. You can solder them, you can do anything. I don't know if you heard, but that board has a relay. It just clicked when I did that. And when it clicks, a bunch of things will happen. One of the very first things that will happen is there is a circuit here called power factor correction circuit. It is something that I will not get into. You can find a lot of videos explaining what it does and how it does it. But basically, it raises the rectified input AC mains voltage from the standard 160 volts that are rectified. What happens after you rectify and filter properly at the 110 volts that we're feeding the board. It raises all that up to 390 to 400 volts. It varies depending on the particular design solution of how it works, but anywhere between 386 and 400, as long as it's stable, it's good. And where it's going to show up is on the leads of those capacitors here. They're all in parallel. It doesn't matter which one you're going to measure. One of the most common failures in all kind of boards is that voltage not showing up after the volt is activated, and telling it to wake up this way is also called activation of the board. I'm not going to measure those now. Again, there are tons of videos, but it does that, and after it does that, it also starts working on the main transformer, which provides a lot of much more power and all kind of different voltages that are further rectified by those diodes here in this case, and output it on other places on the board. So for example, let me stick that here. What you want to do with this board is you want to check the, let's say, the regulated 12 volts. This means regulated, that they are stabilized by a specific device that is going to be holding them even if they're loaded. This is the 12. Let's see what's on that connector here. Here we have 24 volts regulated again. Let's see if we do. Yes, we do. And up there for the LED driver, we do have 36. You got to be careful not to short something because the heatsink is real close. That board is provided, and those are the same. 32, they're just another place where you can get them. So that board outputs without load, and this is a specific thing that you need to know. It is good to know that a board works without load and provide all the voltages. It's not 100% guarantee that this is a functional board. It is, I would say, 99.9. Some boards do have a problem, you have a failure that makes them fail when you load them. That is, they are showing me, let's say, 24 volts here, and it is fine as long as you don't load it. So they're kind of acting of, I'm very brave, look at me, I can do everything, and the moment you actually ask them to do something, they fail. But that's really rare. So this is as good as you can do at home without additional load and additional stuff. And again, it works most of the time. Don't worry about other pins here. I'm not gonna explain those, like AC off detect, that also can go bad sometimes. Don't worry about, in this case, the backlight on, off, and dimming. Again, in case of this particular board, all it takes is the signal from the main board, and it routes it to this connector that goes to the LED driver. It doesn't really do anything. Those signals don't affect the functionality of that board. So hopefully that is helping you. I'm sorry I'm brief, and I'm absolutely certain this is not 100% covering all the bases. I know a bunch of stuff that I'm missing, and there's probably a bunch of stuff that I'm not even thinking about and I'm still missing. But hopefully this will help you test the board, again, with close to 100% reliability. Best of luck as always, and let us know if we can repair your board. Thanks.